Hi everyone, welcome to We Karnataka KCET and Boards. I'm Diksha Kaushal, your chemistry master teacher. And students, your timetable, your date sheet is also out, right? Okay, wait a minute. Let me see. I think Baswa sir has already made a video on that, right? So let us see that. Just give me a second. Wait a minute. Yes. Start, ma'am. Yes, I'm starting. Wait a second. I just saw a video, but I don't know where it was. Yes, timetable out. Okay. Yes, one day ago, second PUC timetable released. The timetable, Baswa sir has already made a video on that, right? Okay, one day ago, that means yesterday. So you can watch that video, right? Okay, so now guys, I'm going to start a DNF block here, right? Just give me a second. Just give me a second. Yes. Huh. So guys, let us start it. Let us start it. It was getting really tough for me to wear the jacket here, right? So let us start the session and we are going to do most important question for your PUC2 for DNF block, and a very predictable questions are asked, and I can guarantee you that you will see the questions from these topics only, from these kind of questions only you will see in your PUC2. So shall I start it? That was the last day of our college. Okay, is it? Now, first question on your screen. Okay, everybody. So I really hope that you all are ready and you all are going to answer it in the chat box. Okay, I'm waiting for your answers in the chat box. Okay, guys. Yes, everybody. Now, the first question is, which of the following characteristics of transition metal is associated with their catalytic activity? Right, with the catalytic activity, which thing is associated? If you talk about a catalytic activity, that means the one, why we are saying that vanadium oxide is behaving as a catalyst, right? Why these transition metals are behaving as a catalyst, nickel, platinum, right? Why? There must be some reason behind that, right? First is paramagnetic. Is this paramagnetic? Is the color of hydrated ion, because of that it is giving catalytic property? Is that high enthalpy of atomization or variable oxidation state? Okay, so the answer is A, B, C, D. Out of that, what is the correct answer here? Everybody in the chat box. The correct answer is variable oxidation state. Okay, the correct answer is variable oxidation state, because because in catalyst we want that the catalyst to change its state, and moreover it is providing the surface for the reaction to happen, right? It has more adsorption. That is the reason that they show catalytic property. So answer is D is the correct answer, right? Next question is, copper if non-transition element, if copper is a non-transition element, is that true or false? Next is, copper has completely filled d orbitals in the ground state. So firstly, there are three non-transition elements in D block, that is zinc, cadmium and mercury, right? And in this list we don't have copper. That is why copper is a transition element, right? So this statement is completely false. Second statement is, copper has completely filled d orbitals. Now copper is actually 29. 29 means it is having argon 18, 4s2, 3d9. Is it? Now we know that this is not the correct electronic configuration. In correct electronic configuration, one electron will jump here and it will be 4s1, 3d10. That will be the correct electronic configuration. Now here, as you can see, in the ground state, the d orbital is completely filled, right? So we can say the second statement is the true statement. That is why the answer is, assertion is wrong, right? Assertion is wrong. That means A is false, but reason is true. So D will be the correct answer again, right? Okay. Yes, that is enough, right? If you go through this like in a very focused manner, right? If you're going through this like, okay, I will not remember anything from there, right, then it is not enough. But you have to focus throughout this lecture, whatever I'm telling you, right? Okay. Now, next is, now we have come to the questions, right? The subjective questions, right? So let us start with the first one. Account for the following. Here first they are asking is transition metal form alloys. First is transition metal forms alloys. Now everybody, is transition metal forming alloys? Yes, definitely. Why there is not? Account for the following. Why transition metal forms alloys? So let us see the reason behind that. Because almost identical atomic radii, we know that D block elements, they have almost identical atomic radii. That is the reason when we mix them, they can easily form alloys, right? Next question that they can ask you is, what is the reason that Cu4 positive is a strong oxidizing agent, right? Now, this is a very, very important question. Guys, all the questions that I am doing here are very important for you. Very, very important for you. I am trying to cover all the questions here, right? Now, Ce4 positive is a strong oxidizing agent. First, you need to know what is an oxidizing agent. Oxidizing agent is that oxidizes someone and itself get reduced, right? That means it itself will get reduced. If I say itself is reduced, can you tell me, if I say it is itself is reduced, now can you tell me in reduction what happens? Oxidation number decreases or increases? When something is getting reduced, reduction, oxidation number is decreasing, right? So here you can say that oxidation number will decrease, right? Oxidation number will decrease here. Now, if the oxidation number is decreasing, from here, you need to see that from +4, it should go to the lower oxidation state. And this is belonging to, this C is belonging to the lanthanoids. And lanthanoids are most stable oxidation state is +3 oxidation state. Right, this is the most stable, this is a common oxidation state of lanthanoids. Because common oxidation state, because after when it is decreasing, or you can say when it is gaining 1 electron, this is +4, when it is gaining 1 electron, when reduction is happening here, it is going towards a more stable oxidation state, then definitely this thing is possible, and hence it is acting as a strong oxidizing agent because itself it is getting reduced. Understood? Understood this? Very good, everybody. Are you able to understand this thing? That why Ce4 positive is acting as a strong oxidizing agent? Because itself it is getting reduced. How it is getting reduced? By gaining 1 electron, it is becoming in Ce+3 state. And that is a common oxidation state of all the lanthanoids. Right? Okay. Now, shall I move to the next question here? First two questions done. Next is write one similarity. You need to write one similarity and one difference between chemistry of lanthanoids and actinoids. Okay, so that is a theoretical question, right? You need to write down the similarity between lanthanoids and actinoids, and there is also write the difference here. So, if you want to, wait a minute, yes. Let's talk about the similarity here. Right, similarity is both lanthanoids and actinoids show contraction and stable in +3 oxidation state. So we talked about lanthanoid contraction. Okay, everybody in the chat box, what is lanthanoid contraction? From here, one more question can be asked. What is lanthanoid contraction? So lanthanoid contraction is, now what happens in lanthanoids and actinoids? You have the addition of these two orbitals. In case of lanthanoids, you have the addition of 4f, and in case of actinoids, you have the addition of 5f. Right? Now we know that I'm going to write it on the next page here. Right? Okay, but I don't have the next page, so what I should do? Okay, so I'll just take one page here. Right? So if you talk about lanthanoid contraction, so lanthanoid contraction will happen because of 4f and 5f, right? Now lanthanoid contraction will happen because of 4f, and actinoid contraction will happen because of 5f orbitals, right? So basically, what is lanthanoid contraction and actinoid contraction? Here you have nucleus and these are the shells, right? Now, if I talk about the f orbital, right, this is the d orbital. Now, I am saying that in the lanthanoids and actinoids, you have the addition of f orbitals. Now, f orbital is a bad friend. It's like a very bad friend. This is you want to stay, you want to go out and party, but this is your friend who is not a good friend. Now, who is a good friend? S is a very good friend. Then P is okay friend. D is not a good friend. F is worst friend that you can have, right? So you are asking permission from your parents, but this D and F, these friends are opposing you. So basically, this is the electron, right? This is the electron. It wants to get protected from the parents, okay? It wants to get protected from the parents. But now if you have a good shielding, that means if you have good bodyguards, in that way you will stay protected. But if you don't have good shielding, you have friends like DNF who are not convincing your parents, who are instead telling your parents that you should not send him there, right? So they are basically gossiping with your parents. So they are the bad friends. They are not having good shielding. So basically this is the shielding effect, okay? This is the shielding effect. So when those orbitals that don't have good shielding are not able to protect the outermost electron from the nucleus, then the size will decrease because the attractions, electrostatic interaction between nucleus and the electron will go on increasing. Reason is because D and F orbitals have poor shielding effect, right? And that is the reason lanthanoid contraction means gradual. One student has written it here, that is Anjali. So Anjali has written it here that this is gradual decrease in the size due to poor shielding effect of 4f orbitals. And what is actinoid contraction? What is actinoid contraction, everybody? What is actinoid contraction? Anybody in the chat box? What is actinoid contraction? Actinoid contraction is the same thing, but here you don't have f orbitals. Here we are saying it is due to the poor shielding effect of 5f orbital, right? Due to poor shielding effect of 5f orbital, right? Okay. Actinoid contraction is even more than lanthanoid contraction. This question also can be asked, that actinoid contraction is more than lanthanoid contraction. Reason being 5f has even poor shielding effect as compared to 4f. 5f is even poor shielding effect as compared to 4f. That is the reason actinoid contraction, the size decreases more frequently, more gradually in actinoid contraction. Okay, is this thing clear to everybody or not? Is this thing clear to everybody or not? Everybody in the chat box. Is that clear? Is that clear? Yes, guys. Now, so similarity is both show lanthanoid and actinoid contractions, and both are stable in +3 oxidation state, right? This is the common oxidation state for lanthanoids and actinoids. Next question is, wait a minute, yes, this is the question. What is the difference? Okay, we have not seen the difference. Lanthanoids are mainly non-radioactive in nature, but actinoids, why we don't study actinoids that much? Because they are radioactive in nature, right? Next is, complete the following equation, right? The equation is CrO72 negative plus OH negative, right? That means, guys, you have two oxidizing agents in your syllabus, KMNO4 and K2Cr2O7, and you need to know all the reactions in NCERT. All reactions in NCERT. You need to Word by word, you need to remember all the reactions here, right? Mentioned in your NCRT related to KMNO4 and K2CR207 because the question are asked from this, right? Okay. Now, complete the following equation in ionic equilibrium. They are telling you that in the basic medium, what will happen to this Cr2O72 negative? So, what will happen in the basic medium? This is converted to CrO42 negative, right? Here it is Cr2O72 negative. Here it is converted to CrO42 negative in the basic medium. Now let us check the oxidation states here because a question can be asked on oxidation states as well, right? So if we talk about the oxidation states here, here it is 2x minus 14 is equals to minus 2. 2x minus 14 is equals to minus 2. So it will be 2x is equals to 12. X is equals to 6. Now very interesting thing you will see here. This is x minus 8 is equals to minus 2 and this is x is equals to plus 6. And this question is asked that you convert it into a compound having the same oxidation state as potassium dichromate. Right, so oxidation state is same, right, but in alkali medium the anion is changing, right? Okay, this question also can be asked to you. Next is account for the following. So now they have given you few things here. First is transition metals and their compounds show catalytic activities. Now guys, everybody in the chat box, we have done this. Reason being because, why it is showing catalytic property? Because it is showing variable oxidation state and it is able to give adsorption. Basically on the surface of the catalyst, you can have the reaction, right? So variable or multiplex oxidation state, variable oxidation state it can show. Ability to form complexes. They provide large surface area for adsorption, right? They provide large surface area for the adsorption. Very, very important point. First is variable oxidation state, ability to form different compounds. Then you have large surface area for adsorption. Because of these three factors, it is acting as a good catalyst, right? Okay. Next is zinc, cadmium and mercury are non-transition, right? Non-transition element. Now, what are non-transition elements? Non-transition elements are those which have fully filled d orbitals in the ground state, right? So, zinc have fully filled d orbitals in its ground state as well as in the excited state. That is why these three are non-transition elements. So, if some, for example, silver, right, it is in the excited state, it is not having fully filled d orbitals. That is why it is a transition element. So, for a transition metal, it needs to have not fully filled d orbital. The d orbital should not be fully filled, right? In this case, zinc, cadmium and mercury, even in excited as well as in the ground state, the d orbitals are fully occupied, fully filled. Next question is, zirconium and hafnium are of almost same identical atomic radii, right? Now, the reason is lengthenoid contraction. Lengthenoid contraction. Lengthenoid contraction, I already told you what is that. Now, what exactly happens because of this lengthenoid contraction? So basically, this is your D block. This is your D, right? From this side, you have the series lengthenoid, where 4f orbitals are getting added here, right? This is the series where you have lengthenum, and from here you have starting of lengthenoids, which are differently mentioned in the periodic table. Now, what will happen because of the lengthenoid contraction? These elements and the elements that are above this series, right? Okay, they will have the same radii because this is what was supposed to happen. Down the group, size should increase. That means radius should increase. Down the group, size should increase, radius should increase. That means if I talk about zirconium and hafnium, then down the group, size is increasing. That means their radii should not be equal to each other, right? But now what will happen here because of the lengthenoid contraction, right? It was supposed to increase. Because of lengthenoid contraction, it is not able to increase. That is why the radii of zirconium and hafnium are similar, right? Okay. So because of lengthenoid contraction or poor shielding effect of 4f orbitals, right? Okay, guys. Okay, everybody. I to feel you guys are not even interested, है ना? Taking everything for granted here, is it? I think you guys take everything for granted. I don't know what you guys want me to do here, right? With so much hard work, I have made these PPTs for you, selected the questions for you. Still, I see like no use, right? It's all useless. It's all thankless. It's all useless, right? Sitting here, right? I was not well. Even then, coming here, teaching you guys. After that, I have my batch class also. But no, it hardly does matter to you guys. Why we have given you 21 days challenge? There was some reason behind that. We wanted you to participate in it, to challenge yourself, so that you can also, see that how you can get marks in PUC too, and also in KCET. We wanted to have that for you, right? That's why I was like, from the morning, I was making notes of solution chapter for you that is going to upload tomorrow, right? I was preparing those notes, like literally making handwritten notes for you with different beautiful colors, right? But I think there is no use, right? Is it? How many of you actually share this channel among your friends? Trust me, like, be very genuine here. Do you share this with your friends? Do you share, if you actually feel this is helpful, do you ever share this with your friends? What do you feel, for how long we will feel motivated teaching just 4 to 5 kids here? Right? If we are giving our time to you, we are giving the best content to you, picking out the best questions, best content for you, isn't it your responsibility to share it with your friends? If that is not your responsibility, then you should not expect anything from us as well, isn't it? I genuinely feel that you guys, like, barely you guys respond in the chat box. Then I am asking you one question, not even a single student have answered me that. Do you share this with your friends? Do you share this? Prabhu, Indumati, Manish, Rishabh, Anjali, do you share this? If you share this, then the effect should be there, right? But I don't feel, I know that you are like, okay, this teacher is teaching, we'll learn, and then okay, this teacher will go. It doesn't matter. It doesn't matter to you, right? So I think that actually hurts a lot. That actually hurts a lot, right? So we guys are doing so much for you, so much for you, right? So if you're not even spreading the word to your friends, then what's the use, right? What's the use, right? So you should, if you respect us, then share this with your friends, share this with your Karnataka friends, share this with your juniors, share this with your seniors who are preparing for KCET, right? And that's all what we ask for you, right? Very good. If you're sharing this, then you are doing your part, right? Okay. Now back to the topic. When FeCrO2O4, so this is a question, right? Previous year questions only. FeCr2O4 is fused with Na2CO3, right? In the presence of air, it gives a yellow solution of compound. Yellow solution of compound A we will get, right? When FeCr2O4 is fused with Na2CO3, you get a yellow color compound, right? Then this A compound, they are saying that this A compound, then it is on acidification, on adding it with HCl, it will give you B. Compound B on reaction with KCl. B on reaction with KCl forms a orange colored compound C, which is of orange color. I think those students who have studied this chapter and reaction of K2Cr2O7, they will be able to answer this, right? C. An acidified solution of compound C oxidizes Na2SO3 to D. Okay. Acidified solution of this C it will oxidize, C will oxidize Na2SO3 to D. Now you need to find out all these things. What is this A? What is this B? What is this C? And what is this D? Right? So clearly it is visible that these reactions are related to K2Cr2O7, the preparation, and this one is the reaction of K2Cr2O7. I'll show you this. Okay, this is how it is. Till here you have the preparation of, till here. This is your C. Because see, K2Cr2O7 is an orange colored compound. Right, so from here only I got the answer that the C is definitely K2Cr2O7. And these three steps are the preparation of K2Cr2O7. And this fourth step is the reaction or property, chemical property of K2Cr2O7. As you can see here, from here we have formed Na2CrO4, right? Then from here, wait a minute, yes, Na2CrO4, from here we have converted into, wait a minute, it should be Na2CrO4, no, wait a minute, it should be CrO4, yes, it should be CrO4, okay, it should be CrO4, so I'm just, wait a second, this should be NaCrO4, okay, not NaCr2O4, right? So this is NaCrO4. Now this in the acidic medium, right, it is converted to NaCr2O7, right? Now this B compound on KCl treatment, this Na will be replaced by this K, right? So it will become potassium dichromate. Now these three are the preparation steps of potassium dichromate, and this is the chemical property of potassium dichromate, that potassium dichromate in the acidic conditions, in acidic condition, they will convert this SO3 2 negative to SO4, right, to SO4 2 negative, right, they will convert this Na2SO4 to Na2SO3 to Na2SO4, right, this they will form. Okay, understood everybody? So these three are directly given in your NCERT, as you can see. These are directly given in your NCERT. The preparation of K2Cr2O7 and KMNO4 and the reaction of KMNO4 and K2Cr2O7. Right? All the reactions are very important. Now then again, mostly the question will be from K2Cr2O7, KMNO4, the reaction based question, or the question will be the reasoning questions from this chapter. Right? So as you can see, now again we are seeing the reasoning question here, that is transition metals show variable oxidation states. Now how come transition metals show variable oxidation state? Because of the d orbital. Transition metals show variable oxidation state because their d orbitals are incompletely filled and different arrangement of electrons are possible, right? I told you transition elements are those which have incomplete d orbitals. That is why different arrangements are possible, different complexes are possible here, right? According to the chemical environment of the metal ion, hence the ions can occupy variable oxidation state. We know that the same transition metal will occupy different oxidation state depending upon what is the ligand that is attached to this, right? We have studied that in coordination chemistry, that depending upon the ligand it can change whether it will form octahedral, tetrahedral, what kind of structure it will form, square planar structure, depending upon the ligand. So that is why it is showing variable oxidation state here. Thank you Ikra, thank you so much Yasmin. Okay, now next question is E0 value of zinc 2 positive to this is negative, this is positive. Simple trick for this question, how to give the reasoning. Whenever they have given something as negative, see, first you need to understand what is electrode potential. E0 means they have given you the reduction potential. First, you need to understand that they have given you the reduction potential here. They have not given you the oxidation potential, they have given you the reduction potential. So it is going from +2 to 0. That means oxidation number is definitely decreasing. That means here they are talking about reduction only, right? So they have given you reduction potential. So see this everywhere. They will give you reduction potential only, but still confirm that, okay? Now, here also it is reduction potential. Now, see one thing. For this reaction to happen, for zinc 2 positive to Zn, for this reaction to happen, if this state is more stable, for this reaction to happen, if this state is more stable, then it will be positive. That means positive. If you want to do something, you will say yes. If you don't want to do something, you will say no, right? If you want to do something, yes, that is definitely enough, bacha. So, if you want to do something, you will say yes. When you don't want to do something, you will say no, negative. So, if they talk about that this E0 value is positive, is negative, that means this change is difficult. If they are saying that this is positive, that means this change is easy to happen, right? In the question itself, you will get the answer, right? In the question only, you will get the answer that what to write there, right? So now, as you can see, what if you don't know anything about what is the electronic configuration? Still you can answer. You don't know anything, but still you can answer. How you can answer? See, this is negative means this thing is difficult. That means this Zn2 positive to Zn is difficult. That means why it is difficult? Whenever you are going in a very unstable situation, then you will find it difficult. So that means this is your unstable and this is your stable. I also tell you the reason behind that. Now, this explanation is for those kids who are unable to understand that which is stable, which is unstable, right? So this is negative means it is going in an unstable situation. This is positive means this Cu2 positive to Cu, definitely it should be more stable. Only then it is possible. Now I'll tell you how is this possible that this is less stable, this is more stable, right? Okay. Now, if you want to write down the electronic configuration of Zn2 positive, that is argon 4s2 3d10, right? Basically, it will be, yes, 4s2 3d10, right? Okay. Now, it is going in an unstable situation. Okay. It is Zn2 positive, no? It is this 4s2 3d10 and here it is 4s, here it is only 3d10, right? So here what we will see that Zn2 positive is a more stable situation, as compared to Zn. That is why you will always say zinc is in Zn2 positive state. Zinc ions exist in Zn2 positive state, right? And here if you see this copper 2 positive means it is having 3d, wait a minute, copper will have 4s1 3d10, right? And it will have 4s0 3d0 or 3d9. So definitely this is going from a unstable situation to a more stable situation. That is the reason this is possible, this is not possible. If something is not possible, that means E0 value is negative there. So here we can write that E0 value is negative. Okay. See guys, it's a very simple concept. Okay, I'll just repeat it again. If you have the E0 value negative, that means that thing is difficult to achieve, right? So difficult to achieve means that will be negative. Now why this is difficult to achieve? Because this zinc is unstable as compared to zinc 2 positive ions, right? But why this is possible? Because copper 2 positive are unstable, as you can see here only, right? But this is more stable as compared to copper 2 positive ion, right? Okay, so that is the reason this is positive and this is negative. Okay, so it means this reaction is say I don't want to reduce into zinc, I am very happy as zinc 2 positive. Okay, why this is very happy as zinc 2 positive? Ma'am, here also you have 3d10, here also you have 3d10. See, we are intentionally saying that we have to convert zinc 2 positive to zinc. If I am saying that you are very successful already in your life, hey, you can be more successful with this thing. Like, okay, I'm already successful. Why I need to shift my job? Why I need to shift my school? If I say that you are already in a very good school, right, and I say that you change your school because that school is also very good, you'll say, why I need to change my school? I'm also in a good school now. In the same way, this is saying I'm already in a stable situation. Why would I gain the electron and become like this 4s to 3d10? I'm already stable, right? Okay, so that is the reason. As you can see, how you will write it in the paper, E naught value of zinc to zinc positive is negative because conversion of zinc to zinc 2 positive gives it completely filled 3d10 configuration. That means from Zn to Zn2 positive it is easy, but we are talking about Zn2 positive to Zn, so that is difficult to achieve, right? So that is why they are saying that already if you convert zinc to zinc 2 positive, already it is in stable state. Zinc 2 positive is already happy. Why would it convert back, right? Next is extra stability gained by Zn2 positive ions, right? Whereas conversion of copper 2 positive, it is very difficult. It is, sorry, very easy task. Sorry. Copper 2 positive, no. Copper is stable. Copper 2 positive is not stable. So it is very difficult conversion. So basically they have written it sort of upside down. But what you will write directly, you will write that zinc 2 positive is stable situation. To get convert to Zn simply, it is very difficult. That is why it is negative. From copper 2 positive is having not a stable configuration. That is why to gain electron and become stable, it is easy. That is why copper 2 positive to copper couple is positive E naught value, right? Okay, understood. Very good evening, Khush Mohit. Very good evening. Understood this, guys? Everybody, this is very important question. Very high probability that they can ask you question related to E naught values. Okay. Next is higher oxidation state of manganese with fluorine is +4, whereas with oxygen it is +7. Now manganese can form +4. Manganese is in the most like maximum oxidation state it is showing. Manganese with oxygen it is showing +7, but with fluorine it is showing +4. The reason is the multiple bonds. With oxygen it can form multiple bonds, but with fluorine it cannot form multiple bonds. With fluorine there is no p pi d pi bonding. That is the reason this +4 oxidation state is maximum that it can have. Right, manganese has highest oxidation state +4 with fluorine, but with this is due to ability of oxygen to form multiple bonds with the metal, right? With what kind of bonding? P pi d pi bonding. P pi from oxygen, D pi from manganese. But whereas fluorine being small size and devoid of d orbitals, it can't form multiple bonds. Okay, so it is not able to form the multiple bonds. That is why with the fluorine, the maximum oxidation state is +4. Okay. Next question is, this is, see, as you can see, this is related to the preparation of MnO2. MnO2, I'm saying this is related to the preparation of KMnO4, that is potassium peroxide, and the reaction of potassium peroxide. Okay, so you can just see this. When MnO2 is fused with KOH in the presence of KNO3 as an oxidizing agent, it gives dark green color compound. Dark green color compound, right? Then this dark green color compound in acidic medium, it disproportionate to give purple compound. This B is our potassium permanganate, right? This is purple color compound. Now here we have two preparation steps of KMnO4 and alkaline. Now these are the preparation steps of KMnO4. Now other things that they are saying is alkaline solution of B, that means this KMnO4 only with Ki, alkaline solution. Very, very important question. Because if you put B, or I'll just directly write KMNO4 here, right? And you put KMNO4 here, I'll just put B only. Reason being because, in the next page it is written only. So why to write it? So that you are able to make a chart here when you see the notes also, right? So B in the alkaline medium, it will give a different product to Ki, but in the acidic medium, it will give a different product, and this is a very, very important question. Okay, this is a very, very important question, that in acidic and in basic medium, it will give you different products, right? So these are the properties of KMNO4. This is the property of KMNO4, right? Okay, now I'll just see what is the property here. With KMNO4, as you can see here, MnO2 plus KOH, that will give you potassium manganate of green color, not permanganate. It is K2MnO4. That means MnO4 2 negative ion is formed here. Okay, potassium manganate. But after reacting this in acidic medium, this will disproportionate, or in acidic medium it will become, or with the disproportionation, it will become potassium permanganate of purple color. These are the preparation steps. Now, after that, when you add in the alkaline medium, Ki is converted into iodate ion. That means I negative in the alkaline medium is converted to iO3 negative, but in the acidic medium, I negative is converted to I2. Okay, it is converted to I2. This is a very, very important and frequently asked properties. Very high chances that they can ask you these things, right? Next is give reasons for the following. Now, let us see the reasons here. Transition elements and their compounds act as catalyst. Now, transition elements and their compounds, why they act as catalyst, right? Now, let us see that why transition elements and their catalysts, they will act, transition elements and their compound act as catalyst. This we have done a lot of time we have repeated this question. It's the third time this question is being repeated. Transition elements and their combined acts as catalyst due to their adopt the multiple oxidation state to form complexes. This is the first. There can be three reasons. First is variable oxidation state. Everybody, other reason is adsorption. They can provide you surface for adsorption. They can exist in complexes. They can form different complexes. These are the three reasons why they show different variable oxidation state, and they can act as catalyst, right? Then the question is E0 value for this is negative. That means from Mn2 positive, from question only you will get an idea. That means from Mn2 positive to Mn, this is a difficult thing to achieve. Difficult. But from Cu2 positive to Cu, it is easy. It is easy. This simply means that this will be unstable. This will be unstable. That is why it is difficult to achieve. This must be stable. From question only you will get an idea what to answer, what to write in the answer. Okay. So here you can say that now if you have written this much, that from Mn2 positive to Mn it is very difficult because Mn is unstable as compared to Mn2 positive, they will give you good marks, right? They will give you marks. They will know that, okay, this person knows that what is the reason behind that. But if you want to make even more impact on the examiner, right, then what you will write here? You will write, because in the end it's all about what you have written in the sheet, right? So what you will write here, we know that manganese has oxidation state, has atomic number 25. So it will be 4s2, argon 4s2, 3d5, right? After losing 2 electrons, it will become 3d5. And here it is 4s2, 3d5. Now, because Mn2 positive is more stable as compared to Mn due to the ionic state here, right? That is why it is difficult to convert back into unstable state, right? What about this one? We know that here it is 3d9 and here it is 4s1, 3d10. So this is more stable as compared to 3d9. That is why this is easy to achieve. So if you want to put more impact on the examiner, you can just write down the electronic configuration as well. Right. Next question is, actinides show irregularities in their electronic configuration. Very simple, because of the variable oxidation state. Right. Due to extra stability of actinoids shows irregularities in their oxidation state due to extra stability of empty, half-filled and fully filled d orbitals. Right. Because of that, they will show you extra stability here. Right. When half filled, you have fully filled. That is why there are so many abnormalities that we don't study them that much. Right. Okay. Next is, give reasons for the following. Now, what is the reason? Transition metals form alloys. First one is transition metal form alloys. Now, why transition metals form alloys? Because of the similar radii. Right. Okay. You can see here transition metal form alloys because of atomic sizes of transition metals are very similar to each other, right? As atomic sizes are very similar, one metal can replace the other metal from its lattice and form solid solution. This solid solution is called the alloy. When you melt them and then you mix them, then you get a alloy. Mn2O3 is basic, whereas Mn2O7 is acidic in nature. See, let us see the oxidation states here. Mn2O3 and this is Mn2O7. This is having the oxidation state as, this is having, I'll just give it one differentiation, yes. Okay, this is Mn2O3 and this is Mn2O7. Right. Now, here it is going to be, this is, wait a minute, this should be Mn. I'm going to write it again. This is Mn2O3. So, this is going to be 2x minus 6 equals to 0. So, 2x equals to 6, x will become equals to 3. Right. What about this one? This is 2x minus 14 equals to 0. 2x equals to 14, so x will become equals to 7, right? X will become equals to 7. Understood? This you will get from here. Now x is equals to 3 here, x is equals to 7 here. Now this is a lower oxidation state, this is a higher oxidation state. Lower oxidation state, that means it will have, like, it has not lost so many electrons. This is Mn3 positive. Here this is existing as Mn3 positive. You can just write it here. You can just write it here that this is existing as Mn3 positive. This is existing as Mn7 positive. So definitely this has more number of electron as lone pairs. This has less number of electrons, right? That is the reason when something has more number of electrons. What is basic character? Basic character is like Lewis base. What is a Lewis base? Which is electron rich, right? Basic is which is electron rich, and acidic is which is electron deficient, right? So you can see that why? Because it can donate the electrons, it cannot donate the electron. That is the reason we can see that Mn2O3 is acidic, basic, sorry, while Mn2O7 is acidic in nature. In words, you can write it like this. Manganese has +3 oxidation state. That is why lone pair availability is more. That is why it is existing as a basic medium, as a basic thing. Then this has +7 oxidation state. That is why it has less electrons. That is why they accept the electron which is acting as a Lewis acid here. Right? Okay. Okay guys, is that clear to everybody or not? Everybody in the chat box, is that clear or not? Next is, you have Eu2 positive is a strong reducing agent. Now, which is a reducing agent? Which itself will get oxidized. Which itself will get oxidized. Now, which itself is getting oxidized, it is a reducing agent, right? That means oxidation number is increasing. That means from EU2 positive, if it is getting converted to EU3 positive, then can we say that here oxidation is happening? Right? Here oxidation is happening. Will it try to get converted to EU3 positive? Definitely. Because lengthenoids are more stable in +3 oxidation state. More stable in +3 oxidation state. +3 oxidation state. Understood? Because lengthenoids are more stable in +3 oxidation state. Next question is E naught value for everybody. E naught value for Mn3 positive, right? E naught value for Mn3 positive to Mn2 positive couple is much more positive than that of Fe3 positive. Now guys, I think you know already that what can be the answer. See, this is couple is more positive. That means this is difficult. This is easy to achieve. And that of this, that means this is difficult to achieve. Now let us see why. Mn3 positive to Mn2 positive. Manganese is having atomic number 25, right? Atomic number is 25. Guys, should I just stop the class? Because if I say, are you able to understand, can I hear yes or no something from your side or not? Or is my voice not audible to you? Is my mic not on? What do you want me to do? Should I stop teaching? At least if I am here teaching you guys, right? Can't you say yes ma'am, no ma'am, nothing like that? Huh? Then after when some teacher resigns, then you say that, oh, I miss that teacher so much. She was such a great teacher. Huh? Once this person has gone out of your life, then you realize their value. If the person is there, then you don't realize their value. Isn't it? I'll not say this again and again. If you can't say anything, I'll stop teaching on this channel. And I am, when I say something, I'm very serious on that. Right? Okay? I am very serious on that. Totally free of cost, we are teaching you here. If you can't even respond on the chat box, then there is no use of me standing here. It's a waste of time. Then I should go and teach NEET aspirants, JEE aspirants who respond. Right? Who respond? So I'll just cancel this class and I'm not going to take class on this channel. Right? If I can't see it. Okay. Fine. So the next question, I will not even talk to you guys. Okay, you want a robotic teacher here? I will behave like that only. I will not even talk to you guys. I'll just say this is it, and that's it. Okay, you don't want to respond? Perfect. I will not talk to you only. Right? Now you will see my face there only. Right? Don't worry. You feel it is very difficult to type yes and no? Go ahead. I can't do anything with that. You don't respect your teacher, I can't make you respect me. Right? Okay. Now, let us see. The first thing is E naught value for Mn3 positive to Mn2 positive couple is much more positive than that of Fe3 positive to Fe2 positive. Now, as you can see here, this Mn3 positive to Mn2 positive, manganese has an atomic number 25, right? This 25 atomic number, if I say that 3 electrons it is losing, for this electronic configuration is argon 18 4s2 3d5. If it is losing 3 electrons, it will lose 2 electrons from 4s and 1 electron from here. It will become 4s1 3d3. And yes, 3d2 3, it will become 3d4. Right, 3 electrons it is losing. No, so it will become, wait a minute, 4s0 3d4. This will be the answer. So answer will be 3d4. Here it is losing 2 electrons, so it will become 3d5. Right. Now, as you can see, this is a more stable state because it is half filled. This is in comparison to this is unstable. So when you are moving from unstable to stable, that means this couple is easy to achieve. But if you talk about this side, where you have Fe3 positive to Fe2 positive. Now, what is the atomic number of iron? Right, atomic number of iron, obviously you're not going to write it down in the chat box. So it's, I'll be totally disrespecting myself here, asking you and thinking that you will reply that in the chat box. So I'll just say this only, right? So iron is having atomic number 26. Saktiv Karman Fiko Niko Jan. Okay, from this particular trick you can remember that this is Saktiv Karman Fiko Niku Jan. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Right? Now, here iron is having 26 atomic number. That means the electronic configuration is argon 18 4s2 3d6. When it is losing 3 electron, it will become 3d5. Right? 2 electrons from this side, 1 electron from this side. When it is losing 2 electron, it will become 3d6. Right? Now, as you can see here, this is half filled. That means this is stable configuration, and this is 3d6. That means it is not half filled, it is not fully filled. So it is an unstable configuration. It is an unstable configuration. So here we can say that when we are going from stable to unstable, it is very difficult to achieve. That is why this couple is more positive as compared to this couple. And these kind of questions are very, very important for you. Very, very important. Next is, iron has higher enthalpy of atomization than that of copper. So now, why iron has higher enthalpy of atomization as compared to copper? Let us see that. Now, as you can see, iron has this, wait a minute, it should be 3d6 4s2, right? This is the electronic configuration of iron. This is the electronic configuration of copper. Can you see one thing here? It has incomplete d orbital. It has complete d orbitals. Now, more than number of unpaired electrons. Now more than number of unpaired electrons in d block, more favorable is the interatomic interactions. Right? See one thing, when we were forming bonds, we know that whenever you have any orbital, it has one electron, it will accept or share one more electron, then it will make a bond with the other atom. Right? This is how chemical bonding happens. Now, this is what they are saying. For the interatomic interactions, the d orbital should be unpaired. There should be more unpaired electrons. More unpaired electrons are definitely available here. Right? Not here. Here all the boxes will be filled, because here you will have 5 boxes here. 1, 2, 3, 4, 5, 6. Not even like this. You will not fill the electrons like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 7, 8, 9, 10. Right? So all the 10 electrons are occupying all the orbitals. There is no unpaired electron here. Right? And this higher atomization enthalpy, Fe having 4 unpaired electron. Why Fe is having 4 unpaired electron? Because if you talk about the d orbital here, it should fill 6 electrons. It is 1, 2, 3, 4, 5, 6. So you are left with 4 unpaired electrons. Here you have no unpaired electron. That is why more the unpaired electron, more is the interatomic interaction, more is the enthalpy of atomization. and hence you can say that iron has higher enthalpy of atomization as compared to copper, right? Okay, as compared to copper, right? Now, next question is scandium 3 positive. Very, very important question again. Scandium 3 positive is colorless in the aqueous solution, whereas titanium 3 positive is colored in solution. Right? What do you mean by that? Scandium 3 positive is colorless. So this means that colorless means no DD transition. So let us talk about scandium 3 positive. Scandium 3 positive. Scandium is having 21. Scandium is having 21 atomic number, right? It is having 21 atomic number. Now, as you can all see, the electronic configuration will be argon 18, 4s2, 3d1, right? It will be the electronic configuration here. Argon 18, 4s2, 3d1. Now we are saying it should be scandium 3 positive. That means you take out 3 electrons from here, then you will be left with only argon 18. 4s will be 0, 3d will be 0. So there is no electrons in d orbital. That means no dd transition. And if there is no dd transition, that means there is no color. The compound will be colorless in nature, right? Okay, the compound will be colorless. Very good, very good, very good, very good. Now, compound will be colorless in nature. Very good, shabash. Now, they are talking about titanium 3 positive. What is the atomic number of titanium? What is the atomic number of titanium, everybody? What is the atomic number of titanium? Everybody in the chat box. What is the atomic number of titanium? We need to check for titanium 3 positive. The atomic number for titanium is 22. That means the electronic configuration is argon 18, 4s2, 3d2. That means you need to take out 3 electrons from here. What we will do? Titanium 3 positive is equal to argon. Take out 3 electrons from here. It will be 4s0, 3d1. And there is 1 electron. That is why there will be dd transitions. There will be dd transitions. Now, if you want to gain marks in your board exams, in your PUC exams, then you need to write all of these things there, right? Writing just this thing there, right? Just writing this thing in the paragraph format will not give you any answer. Here also in this question also you need to draw these boxes telling that how it has 4 electrons, how it has no electrons, right? You need to draw all of these things, only then they will give you full marks in your exam, right? The presentation is very important, right? So, hence here we can say DD transition. That is why we can say titanium 3 positive is having color, right? Okay. Next question is, how is the variability? How is the variability in oxidation state of transition metal different from that of p block element, right? How is the variability of oxidation state in transition metal different from the p block? See, variability of oxidation state. If you talk about the oxidation state in p block, it is variable to only 1 unit. But in B block, the transition state is existing from +2 to +7. That is a huge gap. In P block, you don't have this much gap in the transition state, right? So here you can write that in P block elements, the difference in the oxidation state is 2. Like in the transition element, the difference is only 1. It is existing +2, +3, +4, +5, +6, +7. All of them are existing. But in P block, you either have +2 or +4, right? These kind of these kind of oxidation state exist in P block, right? That is the difference. Next question is out of Cu positive and Cu2 positive, which is unstable in aqueous solution, and why? Now, this is a question from disproportionation reaction mentioned in your NCERT, right? Okay. Ma'am, why you're giving answer in paragraph? Oy hoy. I am giving you, I am saying that you need to write this also, you need to write this also. If you write only the diagram, you don't like mention everything here, they will not give you full marks. If you just mention the paragraph, maybe they will give you, this is 3, maybe if you need 1 marks for this question, maybe they can give you, it depends on their mood, okay, of the examiner, right? But if you give them proper diagram also, what I am saying is, write it in the paragraph form, that is important, but also give a flow chart or any reaction or anything, diagram, that they can just directly see the diagram and give you the marks. Because the reality is, the examiner will not have that much time to read out everything. But if you don't write, they will say that this person has not filled the sheets. That is the mentality. This is what I am telling you. Whenever you are going in the exam hall, just remember one thing the examiner is thinking. They are provided with the P block is not in the syllabus. I know that, but the comparison, right? This is in the this comparison is in the classification. In 11th class there was this comparison, but yes, you can skip this question for that, right? But now remember one thing, whenever you are writing the exam, write the paragraph along with any reaction, any suitable reaction if it can fit there, or make any flow chart so that simply the teacher can go through the paragraph. If they don't want to go through the paragraph, they can just see your flow chart and give you marks, right? This is how science questions are attempted, right? Okay, now next is Candium. Also you need to write this also, you need to write this thing also, you need to write this whole thing also. Hello, hello. Now is this audible? Okay. I think now it's audible, right? Okay, so where I was. Okay, I was just telling you this question, that dichromate ion conversion in alkaline medium, it is converted to chromate ion. Dichromate is orange in color. It is orange in color, and this is yellow in color. And this is yellow in color. You need to write this reaction, write this paragraph. Right? Okay. Next question is, chemistry of actinoids is complicated as compared to lanthanoids. Give 2 reasons. First is, now this question is completely your theoretical question, okay? Now, chemistry of actinoids is complicated as compared to actinoids. What is the reason? Here you need to form it in the points so that they are able to see that you have formed 2 points, right? So make it in points here. They show multiple oxidation states, namely +5, +6, +7. We are talking about actinoids here, respectively, which permits to form formation of higher oxidation state through removal of periphery electrons. So basically, we are talking about that actinoids has like a variety of oxidation state, exceptionally high number of oxidation state it will show. That is why it is very difficult to study the actinoids. Next is actinoids are very radioactive elements and have strong propensity to the complex reaction. These difficult words you don't need to write. Just remember that they are very radioactive. That is why it's very difficult to study them. Right? Just remember this thing, that they are very radioactive, right? And they have very unstable isotopes. And some actinoids are formed naturally by radioactive decay. That is why it is very difficult to study them. Right? Last question of today is, the elements of 3D series are given scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. They are asking you, write the element which shows maximum number of oxidation states. Maximum number of oxidation states. See, one word answer it is. Maximum number of oxidation state is shown by manganese. Okay, it is shown by manganese. +2 to +7. Right? From +2 to +7. Then there is, which element has highest melting point? Which element has highest melting point? Wait a minute. Yes. It was, yes, chromium. Right? Which element has highest melting point? The answer is chromium. Right? Chromium has highest melting point. Next is, which element shows +3 oxidation state? Only +3 oxidation state is shown by scandium. Right? It shows only +3 oxidation state. Which element is strong oxidizing agent in +3 oxidation state and why? Which element is strong oxidizing agent? That means itself want to get reduced. That means from +3 they want to reduce itself. Which was the element that was easily able to reduce itself from +3 oxidation state? And what is the reason behind that? Everybody. So here the answer is manganese. Right? Reason being, +3 oxidation state, it can show variable oxidation state. Right? From +3 oxidation state, it is having existing in 3 electrons, take out 3 electrons, it will be 3d4 and here it will be 3d5. So that is why it wants to gain 1 electron and get itself converted into the more stable oxidation state. Hence, it will gain 1 electron, itself will get reduced and it is called as a good oxidizing agent. Right? Okay, everybody? Okay, everybody? So guys, that was all about, yes, manganese because of the oxidation state. So guys, that was all about PUC DNF block questions. The PDF I will send you on KCET Karnataka, right? V Karnataka, KCET and Board's Telegram channel. The link is in the description there. And I really hope so that in coming lectures, I'll see more interactive students here, right? Because otherwise it's very difficult here. I can't mention that again and again. I really hope if I'm mentioning something, right, that you understand that why I'm mentioning that again, right? Okay. Yes. Okay then guys, bye bye, take care, and tomorrow one very important session, and I have made very beautiful notes for you, like really beautiful notes for you, right? And I'll send you one photo on my Telegram, right, of solution chapter notes, and the recording you will get tomorrow at 5 p.m. here on this channel, right? I have included KCET questions as well. I have included the full theory part in my handwritten notes. Okay, yes. Okay, bye bye, take care, see you all in the next class, bye, and I'm waiting for your comments in the comment section.